What's up, everybody? In this video, we're going to cover USACO's 2022 January contest at the silver level. Problem number 1, searching for soulmates. Let's read it together. Farmer John's cows each want to find their soulmate, another cow with similar characteristics with whom they are maximally compatible. Each cow's personality is described by an integer from 1 to 10 to the 18th. 10 to the 18th. That's a big number. Probably going to need long longs for this then. Two cows with the same personality are soulmates. Okay, a cow can change her personality via a change operation by multiplying by 2, dividing by 2 if only if pi is even, or adding 1. Okay, so given some number, like for example, 7, we could multiply that by 2 to turn it into a 14. We cannot divide it by 2 because it's not even, but we could add 1 to it. So I could go from 7 to 8, and then if I was at 8, I could divide by 2 and get 4. And then I could divide by 2 again and I get 2. So basically, each personality of these cows, pi being the personality of cow I. So if, for example, cow 3 has personality 6, then I would say that if I is equal to 3, that personality 3 is equal to 6 in that particular case. So basically, the personality of each cow. Farmer John initially pairs up his cows in an arbitrary way. He was curious how many change operations would be needed to make each pair of cows into soulmates. For each pairing, decide the minimum number of change operations. The first cow, so we're trying to find the fastest way to get there. The first cow in the pair must make to become soulmates with the second cow. So the first one's got to change to match the second one. All right, let's look at the input and output format. Input arrives from terminal standard in, so you can just read it as if it's being typed. The first line contains n, 1 through 10. Okay, so how many cows there are. It's the number of pairs of cows. Each of the remaining n lines, here's 6 lines, for example, describes a pair of cows in terms of 2 integers giving their personalities. The first number indicates the personality of the cow that must be changed to match the second. So 31 has to become 13. Output format, printing to the terminal standard out. So we just print it to the screen. Please write n lines of output, write 1 for each one of those. For each pair, print the minimum number of operations required for the first cow to make her personality match that of the second. And minimum makes sense because if you could do, I mean, there's no maximum. You could always just keep dividing by 2 and adding 1 and loop that infinitely. But we're trying to find the shortest path between A and B. So, for example, with 31 and 13, if I had 31 and 13, I want to try and get 31 to become 13. So the only thing I can do is I could multiply by 2, which makes it further from 13. I could divide it by 2 if it was even, but it's not. Or I could add 1 to it, and that looks like that's my only option. So 31 is going to become 32. At this point, I could add another 1, but that would just be moving away from 13. So dividing by 2 makes the most sense. That'd be 16. It's getting closer to 13. We can divide by 2 again to get 8. And then if I were to add, I could get to 9, 10, 11, 12, 13 potentially. Let's see how many operations is that. 1, 2, 3, 4, 5, 6, 7. That's 8 operations. That seems to have worked. Let's look at 12 and 8. 12 and 8. 12 divided by 2 is equal to 6. And then could you plus 1 to become 7, plus 1 to become 8. And then I've got 3 operations, and that's 3 right there. This problem isn't as simple as you might think, though. For example, let's say like I have 12 and 20. 12 and 20, if I were to just add, I could go 12 to 13 to 14 to 15 to 16 to 17, 18, 19, and 20, and that would be 8 operations. Or potentially what I could do is I could divide by 2 to get 6. And then from there, I could add 4, 7, 8, 9, 10. And then I could multiply by 2 to get 20. And that would be 1, 2, 3, 4, 5, 6 operations instead of 8. Or if I was at 6, I could further divide by 2 again to get 3. And then I could add 1 and then 1 again, which would be 5. And then I could multiply twice to go to 10 and then to 20. And that would be 1, 2, 3, 4, 5. That's actually also 6 operations. So there's different ways we can go about doing this. If you have a paper and pencil by your desk, I would recommend using this time to play around with a couple different numbers and see if you can figure out what kind of patterns there are here. and then check back in, and we'll see if we got it figured out. All right, so I'm going to come up with a couple basic premises and basic rules for solving this problem. The first is when I'm going from one number, for example, let's do this 997 to 120, 997 to 120. So in order to get these numbers equal, at some point, this first number has to be less than or equal to this number. I mean, that's just kind of a given. We have to work our way down and then hopefully get to 120. If I manage to get to, for example, 119, then I could add 1 to get up to 120. Or if I manage to get down to 60, I could multiply by 2 to get to 120. So essentially what we're doing is we're trying to figure out what are some of the numbers we can create. But since I know I want to make this one smaller, and I know that there's no reason to ever divide by 2 after multiplying by 2, there's no reason to multiply by 2 at all. So everything about this one is trying to make this number lower. So let's just kind of trace through that real quick. We're going to run this number from, I'm actually going to make these a little bit smaller. We're going to run this number from 997 all the way down to 1. So from 997, I would have to add 1. That would give me 998. Then I could divide by 2. That'd be 499. From here, I would have to add 1 to get, I'm not going to draw arrows, so it's going to take up too much space. 998, 499. Let's do this. 998, 499. Add 1 gives me 500. Let me draw that 9 a little better. From here, I go 250, 125, 126, 63, 64, 32, 16, 8, 4, 2, and 1. Okay, now on the other side, I've got this number 120. At some point, I'm going to have a number that's smaller than 120 or equal to 120. For example, 63 is one such number. I then need to try and figure out how do I get from 63 back up to 120? Since I can add 1 and multiply by 2, essentially what that means is that for 63, I could double that to become 126, or I could add 1 to make that 64. Now, in working our way up to 120, it is always more efficient to add prior to multiplying. So if I was going to go from, for example, if I had a number like 63 over here, and I want to try and get that up to 120, I would always want to actually, I would always want to add before multiplying. If I can add and not go over, I would want to try adding. What that means then is that I can work backwards from the 120 down to 60. The fastest way to get to 120 from 60 would be to multiply by 2. From there, the fastest way to get to 120 from 30 would be to multiply by 2 twice. And then 15. From 15, I would have to get from 14, then from 7, 6, 3, 2, and 1. So working its way back up, I'm either adding 1 or multiplying by 2. Working its way down, I'm either adding 1 or dividing by 2. Now, once I have these 2 sets of numbers, what I need to do is then try to figure out what's the quickest way to get from this side over here to this side over here. So what we're going to do is we're going to try basically every possible pairing of these numbers. Say, like, for example, I was to bridge from, let's do the 8. If I was to bridge from the 8 to the 14, for example, the fastest way to do that is going to be to add 6. That would take 6 moves, just plus 1, plus 1, plus 1 to get from 8 to 14. Plus the number of steps down I had to take would have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then the number of steps up I would have to take would be 1, 2, 3, 4. So I would have 11 to get down to the 8, 6 to get from 8 to 14, and then 4 to get from 14 up to 120. And that would be if I chose those 2 as a pairing. So essentially what I'm trying to do is I'm trying to figure out, based on having generated these 2 sequences of numbers, one sequence of numbers which is starting from 997 and working its way down, one sequence of numbers which is starting from 120 and working its way down, although with different rules, because remember with the left side, as I'm working my way down, I can only add 1 or multiply by or divide by 2. On this side, as I'm working my way down, since it's going to be going in the opposite direction, I'm essentially subtracting 1 or multiplying by 2 because I'm solving it in reverse. Later on, when I go this direction, heading up, that'll be adding 1 or multiplying by 2. From there, every single one of these gives me a pairing. And essentially what I'm looking at is I'm looking at every possible pairing as long as the number on the left is less than the number on the right. So for example, using 32, I could go from 32 to 60 by doing plus 28. Using 16, I could go from 16 to either 30 or to 60 by doing plus 14 or plus, it's too large of a number, I don't want to bother. From 8, I can get from 8 to 14, or from 8 to 15, from 8 to 30, from 8 to 60, from 8 to 120. From 4, I can get from 4 to any one of the numbers as low as 6. Now, generally speaking, the further down you go, the more this addition is going to count. Because as I'm doing my plus one, then later when I'm multiplying by 2, all those plus ones are going to get multiplied by 2 as well, effectively. So, for example, from 4 to 6, if I was going from 4 to 6, and I do plus 1, that gets me up to 6. Then later when I do, for example, I had to add 1, but then when I do 7 times 14, the 2 that I added in to get it from 4 to 6 is also getting doubled. So that's giving you some synergy as you work your way back up. So for the most part, you're always trying to find the lowest value, vertically the lowest value. That's not always the case though, because sometimes working your way down takes a little bit more than simply adding. So you will have to try every combination. So if I were to use this in terms of like index I and index j, for example, then this I would call I0, this I would call I1, or J0, excuse me. J0. And then I1, I2, I3, I4, and so forth. And J, 1, 2, 3, 4. Now, the way you keep track of that, you have your options for that. I'm going to draw it as a table, although I don't necessarily recommend doing that because that may end up being a lot of data. But if we were to represent I over here in terms of 0, 1, 2, and 3 steps, and J over here in terms of 0, 1, 2, and 3 steps, then we can figure out how much work it takes to get from the left side to the right side, and we can record that. In this case, actually, the 0, 1, 2, 3, none of those numbers are much larger. But if I were to have, let's see, where's the first one? The first one's really going to be down here. It's 5, 6, 7, index 7. So for example, on ... index row 7, then from row 7 to index 0, which would be from the 63 to the 120, I would have 7 steps down. I is going to take 7 steps down, plus the difference between the two, 63 and 120, which is, was that 57? Plus how many steps up I have to get. Since J is 0, there's no steps up. So 7 plus 57 would say that that's 64. So to get from the 7th number down to the first number would take 64 moves. To get from the 8th number, which is 64, that would take 8 steps down plus 56, which would be, that's also 64, isn't it? If we go further down to 9, 8, and then that's number 9 for the 32, then I've got 32 to, for example, 60, which is going to be 9 steps down, and then plus 28 to get from 32 to 60, which is 37. And then 1 more step to get from 60 up to 120, so 38. So that'll be 38, which you can see is much smaller than 64. So essentially what you're looking at doing is, let's clear this out and start this over. So for 997, and for 120, we want to create lists where each one of these things is the first item in the list. And then we follow a progression all the way down to 1. In 997's case, we're trying to go lower. So all we're going to do is add 1 or divide by 2. If it's odd, we add 1, 998. If it's even, we divide by 2, 499, 500, 250, 125, 126, 63, 64, 32, 16, 8, 4, 2, and 1. For this one, we're going to do the same thing, except this time, since this is being done in reverse, we'd really be solving it in that direction. It'll be subtracting 1 if it's odd instead of multiplying, or instead of adding 1. So this will go from 120 down to 60, down to 30, down to 15. From 15, we will have gotten there from 14 by adding 1, then 7, then 6, 3, 2, and 1. And then for every single pair of numbers from I equals 0 and J equals 0, for every single pair of numbers, we're trying to figure out the number of moves to get from that number to that number. For example, if I were to try to get from, I can't get from I to J because I is larger than J. But to get from any index to any other index, for example, if I were to choose the 32 here, it's whatever that index is. That's how many times, that's how many times you had to take steps starting from the 997, 3 steps, 4 steps, 5 steps, 6 steps, 7, 8, and 9 steps to get to the 32. To get over here on this other side, it would be however many steps you had to go to get back this way. So this would be like after 1 step, 2 steps, 3 steps, 4 steps, 5, 6, 7, 8, 9. And then for any given pair, I and j, for any given I and j, then the number of moves is going to be I, which is how many times you had to operate on the first cow, plus j, which is how many times you have to operate on the second cow, plus whatever the difference is in the array at j minus the array at I, which is all just going to be plus 1, plus 1, plus 1 to get from one side to the other. Because essentially what's going to happen is once we get down to a certain number, we'll have to just add ones to get to whatever that next number is. And essentially we're taking all of these and trying to find what is the smallest possible value such that the number of steps that we conduct upon I, the number of steps that are conducted on the j side, as well as the difference between the two in order to do all the plus ones necessary to bridge that gap, where those are going to add up to the smallest possible value. Looking at that again, just taking this first problem, if I have 31 and 13, we'll run it with a simple case. 31 is going to go from 31 to 32 to 16, 8, 4, 2, and 1. From 13, we would do minus 1 to get to 12, then 6, 3, 2, and 1. Remembering that as we step down, this is 1 step down, 2 steps down, 0 at the top, 3, 4, 5, and 6. And for this one, this is 0 at the top, 1 step down, 2, 3, 4, and 5. When we then draw out our table, let's see if I can squeeze a table into here. For 0, 0 can't get to anything. 1 can't get to anything. 2 is 16. I can go from 2. No, I can't get there either. 2 doesn't go anywhere. Let's start with index 3 then. From index 3, which has a value of 8, I could get to index 1. That would take 3 steps down, plus 4 to get from 8 to 12, plus 1 step up, which would be 8 total steps. I could also go to the 13 by taking 3 steps down and then adding 5 to get from 8 to 13, and then 0 steps. So it'd be 3 plus 5, which is also 8. That'd be from index 0. Index 1 and index 0, both 8. Moving to index 4, row 4, to get from the 4 to the 13, I've got 4 steps down. And then to get from 4 to 13, I'd have to add 9. So 4 plus 9, which would be 13 steps. To get to index 1, it would be 1 less to add, but then 1 more I'd have to add over there. So it's still going to be 13 steps. To get to 6, it would be 4 steps down, and then plus 2, and then 2 steps up, down, 2 steps back up. 4 steps down plus 2 is going to be 8. I can't get to 3. From index 5, row 5, to get from 2, 2 could go, this is index 5, yeah, so from 5 to index 0, I'd have to add 11, so it'd be 5 plus 11, which is 16. To index 1 is the same thing, 16. To get to the 6, I'd have to do plus 4, so it's 5 steps down, plus 4, and then 2 steps back up, which is 11. To get to the 3, I'd have to go 5 steps down, plus 1, and then 3 steps up. So 5, 6, 7, 8, 5, 8, and then 1. 5, 8, and 1 is that 14. And then from here, this would be 5 steps down and 4 steps back with no addition. No, that's not 14. What is that? It'd be 5 and 3, which is 8. It would be 9. And this one would be 8. Okay, so then once we're done, we would just look in here, and it turns out there's actually a lot of different paths that equal the 8. But whatever the smallest number then is in that grid is going to be what our solution is. So as a quick recap, generating your list of numbers from 31, however many steps down through the array you have to go. That's how many times you committed operations. For this one, using the same process, except subtracting 1 and dividing by 2. However many steps down that was how many steps that process takes. Whatever the difference is in the values, that's how many plus ones you have to do to get across from one side to the other. And then you're just trying to find your shortest path. So ultimately, your solution is going to be some form of steps down, steps over, and then steps up. And you want to just minimize that. The number of steps down is always how many steps you had to get, like how far down in the list that is. This is likewise going to be how far down the list this is. And then the bridge is going to be just the difference between those two values. Once you've checked every possible combination, that should give you your lowest value. Alrighty, good luck coding it, and I'll talk to you on the next one.